press D, it's going to move to the right. Yay, it's working. Hey guys, welcome back. On this video, we'll be making our player movement. That's what we're going to be working on in this video. Before I say any other thing, we'll be using variables for the code, and we'll also be using if statements, and we'll be taking player inputs to help the player move. So let's get right into it. And yay, we'll still be using C# to program. We're going to continue from where we stopped. So you're going to open your project and also open your Visual Studio or whichever application you're using to write your code, and let's begin. Okay, so to make our player move, we need to accept input, because right now if we press play, it's still going on the force. Like, remember when we coded the force, so it's only going to push the ball forward, but we need to make the ball move left and right. As you saw in the video, as you can see in the video, we're moving left and right, and we're also jumping in the video. So we need to be able to do that in our game. So I'm going to show you how to do that. So go back to Unity, open player, double tap on our player movement script, and we're going to say, go to your code under the update, because you know we have to be able to move the player every time, not on the start method. Remember, update is called every second, so we want to be able to move our player as the game is playing every second. Yeah, so we're adding force. Remember, we're adding force for the player to go forward. So this is not the best method, but for beginners, this is the best thing for you to know. Like, this is what you can use and start and then build. And if you want to make your game better, you can also go and browse and check for more. But for now, to add force, to move your player left and right, and to also jump, we're going to add force to those directions. Does that make sense? So rb.add force. No, let's just use this one here. rb.add force. This was to the z-axis. Z-axis means forward, x means left and right, then y means from up and down. So if we're going to make a player move right, we're going to add the force to the x, and that's going to be positive. Because if we say 60, it's going to add the force to the player 60 on the x-axis, meaning the player is going to go right 60. Yeah, but if we put minus 60, it's going to be on the x-axis, and it's going to go left. So let's put say 50 on the x, and let's reduce this to 0. So let's reduce this to say 200, because we don't want the player to move too far. Yeah, to 200. So when we play a game, the player is going to move right and then move forward a little bit. So compiling, and done. So we're going to click play. Yeah, you saw player moved right as we wanted it to. So that's adding force to. Yeah, okay, that's true. So now we're going to reduce this because we need to see move slowly. Let's say 10. Yeah, add force to the x-axis 10. If you don't understand what I just did in Visual Code, you can see it's moving right. If you don't understand what I did in the code, you need to watch my other video so you can understand that this is the x, this is the y, and this is the z. X is for left, that is left and right as my cursor is moving. Then y is for up and down. Then this, since it's a 3D game, the last one is z-axis. Z-axis is for forward and backward, which I can show you now on my screen because my screen is 2D. So as you can see in the Unity, when we played, our player moved 10 force to the right, like the force pushed it by 10 to the right, as you can see. So if we want to be able to move our player left and right, we're going to use if statement. If statement is a code, it's a condition in C# for Unity. So if I say if 3, this is how it's written. These are the if statements written, right? If, then 2 brackets, and then 2 curly brackets. That's how it's written, right? If, and then 2. Let me zoom this in. Okay, so this is where we put our code. So whatever we put here will run if this condition is met. That's how this works. So I can say if 3 is greater than 2, and we know 3 is obviously greater than 2. So when we run this program, it's going to check if 3 is greater than 2, and since 3 is greater than 2, it's going to run whatever code we put in between this curly bracket, in between the if statement. So if we say if 1 is greater than 2. Obviously 1 is not greater than 2, so if we run this, whatever is here won't run. Whatever is in between here, if we write this won't work, this won't run, because 1 is not greater than 2. So we get that. So we can say we only want our player to move right when we press D, because on our keyboard, WASD for gamers, you guys know, to move left is A, to move right is D for the games you play on your keyboard, on your laptop, sorry. So to move right, we need to press D. And how do we check if the player is pressing D? We press input. Input is a class for Unity. So input dot get key D. This is how it is written. So input, that's to collect the player's input. Then what input? It gets key. And we're getting a key on your keyboard, and the key is D. So if a player should press D, what do? We should write this code inside. So if a player should press D, let's return this back to the normal. Yeah, let's put this to 300 so you can be moving forward. So if a player should press D, add force to the right. Let's change it back to 0, so it's only add force to the right and not increase the speed. This one will be running every second, meaning the player will be going forward every time, and our player will only move right if we press D, meaning we have added a way for our player to move right by pressing D. So to add 10, let's reduce this to say 5, so that it will add by small. And we're going to add delta time to it, so that it will also check the frames and make sure it's counting properly. So we're going to copy this and add it to the value that we are considering. So because here we are adding it to move the player forward, so we're adding the delta.time to the value that we increased. But here we're using D to move the player right, D on our keyboard to move the player right. So we're adding the delta time to count the frames for the right. So just write it like this and it's going to work, I promise you. So if we save this and go back to our game, our player should be moving forward till we press D. He should be moving forward till we press D. So now I'm pressing D now. But that's not working. Let's go back to our game. Okay, let's increase this to 10. Okay, let's increase this. So if this doesn't work, then we'll know what's wrong. Okay. So if I click play, press D. It's still not working. It's still not working. It's still not working. Oh, it's working. It's working. It's working. It's working. Hey guys, it's working. So let's increase this to say 100. So if I should press D, it was too low, so we couldn't say it. I forgot. So if you should press play, press D, it's going to move to the right. Yay, it's working. So if we press D, as you can see, when we ran the game, every second the computer was checking if we are pressing D, move the player to the right. That's add 100 force to the player to the right, to the x-axis. Remember, this thing is the x, is the y, this is the z. Never forget, it's vector 3. So what do you think should be the statement to move to the left? Obviously, if we're pressing D to move to the right, we're pressing A to move to the left from our keyboard. Yeah, so A. So how do we move to the left? That's the opposite of 100, which is minus 100 on the number line. Yeah, so 100 is for right, then minus 100 that is opposite direction of the x-axis. Yeah, so this should work. So that means if we press A, it should move to the left. If we press D, it should move to the right. So let's play and see that's working. Did we save? Yeah, I'm sure we saved. So A, yeah, it's moving to the left. Right, yep, that's cool. So let's increase the force so that we can see it before it goes far, because our camera is not following the player yet. So let's increase to 200. Okay, so save that, go to Unity, click play, left, pressing A, right, pressing D. So yep, let's optimize that and make that let's make it look good. So increasing this to say 500, then 500. Yes, So that should give us that feel that we saw in game. So left, right, right. Okay, that's good. Let's increase it more. 700. Let's increase this to let's reduce this to 100 so that it moves slowly, so we can see the movement and make sure that's okay. Okay. Yeah, left and right. Yes, adding force to the different as well. Oh, that's crazy. So we're almost done with the video. Now what I want you guys to do is to create a variable. Remember I said we're going to use a variable, so we're going to create two variables. Yeah, so the first variable is going to be public. That's how you make variables public, so we can see it in Unity, so that we can access it from the other scripts, as from other codes. Public speed, that's the name of the variable. Sorry, public speed, that's the name of the variable. And what type is the variable? Integer. Sorry, let's use float. Yeah, let's use float because our speed can be point something or point that. So public speed, and then that's for the speed of the player. Then another one, another value for let's say sideways speed. Yes, that's not smart, but sideways speed, so that we can edit this information from the Unity. So now I can see speed is equal to 200. Yes, so 200f because it's float, so you'll use this for float. Then this is equal to what was here, so let's put 800f. So now we can carry this speed, since it's a variable, and a variable is a box that contains values. A variable is a box that contains values. So speed contains 2000 float force. Yeah, you get me? So if I should put 2000, okay, sorry, let's change this to 200. Yes, so if I should put speed here, it's going to be okay because speed is a value. Yeah, so yeah, as you can see, it's referencing this. So sideways speed, I can put sideways speed here. So sideways speed. Then here I'll put minus sideways speed. That means minus what's sideways speed? 800. Yeah, so if you go to Unity, you see that we can edit this from our Unity. So Unity. So now if we scroll down here, you can see here sideways speed. This sideways speed 0. Why is sideways speed 0? Sideways speed equals to this. Yeah, it's equals to 800f. So why would you say 0? Public float sideways speed. Okay. If we press play, okay, that was fast. Okay, we can edit it from here. So let's change this to 200, and then sideways speed should be 800. Okay, let's just be 100 so that it moves very slowly. Yes, so play, and you see that it will work from here. Yeah, left, right. And now the last thing before we round the video up, Unity loves when you use fixed updates for your movements, for your physics. Updates is not very, very smooth, but when you use fixed update, everything is cool, everything is okay. So make sure to change this to fixed update, and that's where we're going to stop for today. That's all for the player movement. I'm sure you guys are going to be asking, because in the video we're jumping, but the jump is for another video, so make sure to stay tuned so you see how we're going to make the jump work well. So for now it's just the left and right. So this is already looking cool. Yeah, so we can add some obstacles. Say right click, let's say add a cube, so take it up in the scene view, then drag it forward, then shift it to the right. Let's give this red, drag red and drop on it, then drop it down. So if we press play, we can actually control our ball not to hit the cube. So left, right. So left, you see, we can also hit it. You see, we hit the cube. We can also move left so that we can continue going forward. Yeah, so let's change the speed to normal player. Remember speed that we made, so let's change to like 300. So go forward, does the cube by moving left, you see, so a player can move now. So That's all, guys. Thank you for watching. Make sure to stay tuned, and the next video is going to be camera, the player camera, so that the camera will follow the player, and then we'll be seeing the player as the player moves and pass obstacles. Thanks, guys. See you guys later.